For test 4, I'm doing the problem number 25 from page 779 in the textbook. And this problem is asking whether the summation as n goes from 1 to infinity of the quantity negative 1 to the n power times n plus 1 times 3 to the n power over the quantity of 2 to the 2n plus 1 power is conditionally convergent, absolutely convergent, or divergent. So to do this, I decided to do the ratio test. And what I did was I set this function equal to the limit as n goes to infinity times the absolute value of the negative 1 to the n plus 1 power times n plus 1 plus 1 times 3 to the n plus 1 power over 2 to the 2n plus 1 plus 1 power, all over the initial function equation. So, in the next step, I just simplified this a little bit. I changed the n plus 1 to n plus 2, and the 2n plus 1 to 2n plus 3. I did this because you get, when you multiply 2 over the n plus 1, you get 2n plus 2, and then you add the other one, you get 3. And then I brought the initial function up and flipped it, so it's now multiplying instead of dividing. So then in the next step, I brought out some of the values. I changed it from negative 1 to the n plus 1 to negative 1 to the n and negative 1 to the first power, which is just negative 1. And I did the same thing with 3n plus 1. I made it 3n times 3, or 3 to the n times 3. And then for the 2 to the 2n plus 3 power, I recognize that in the initial equation we have 2 to the 2n plus 1 power. So I divided the 2 to the 2n plus 3 power into 2 to the 2n plus 1 times 2 squared. So that way, this cancels out with that, this cancels out with that, and that cancels out with that. So then in the next step, we're left with negative 1 times 3, which is negative 3, times n plus 2, over 2 squared, which is 4, times n plus 1. And this is all still the absolute value. So then I pulled out the absolute value of negative 3/4 in front of the limit. And then, so the absolute value of negative 3/4 times the limit as n goes to infinity of the absolute value of n plus 2 over n plus 1, which gives me the absolute value of negative 3/4 times infinity over infinity when we plug in infinity for n. And since this is indeterminate, we have to go to L'Hopital's rules. And to do this, we take to solve for L'Hopital, we do the derivative of the top, n plus 2, which just ends up being 1, over the derivative of the bottom, and the derivative of n plus 1 is just 1 as well. So then we end up with, we still have that, the absolute value of negative 3/4 times 1. The absolute value of negative 3/4 is 3/4, which is less than 1. So we get that this equation, or this function, is absolutely convergent.